This is the second part of videos for section 1.3 in pre-calculus. So we talked about all things factoring last time, and this one we want to talk about simplifying rational expressions. So first of all, keep in mind a rational expression, rational just means fractional, okay? A fractional expression. Now, I know you know how to simplify fractions. I know you wouldn't have to do much thinking at all to know that 24 over 9 can simplify to be 8/3. But for just a minute, I want you to think back to your, gosh, I don't know, fifth grade roots when you first learned to simplify a fraction. And so your teacher might have said, well, hey, think of some things you can multiply to get 24. And you might say, oh, I could multiply 8 times 3. I'm not saying that's the only one, but maybe you did that. And for 9, you might say, oh, that's 3 times 3. And then what your teacher told you was, hey, if they're both being multiplied on top and they're both being multiplied on bottom, then it's okay to cancel if you have the same ones on top and bottom. And so that's why what you're left with right here is 8/3. Okay, now I know you don't actually write that out. You do all that in your head and you don't even think about it anymore. But the point I'm trying to make is it only worked because this was multiplication. If you had something like 8 plus 3 over 3 plus 3, it would not have been okay to cancel those. It does not work that way, only if it's multiplication. So with that in mind, the directions say, which of the following illustrates this principle, meaning that they have to be multiplied? Well, on the first one, because 3 is being multiplied by the parenthesis and 3 is being multiplied by the parenthesis, it's okay to cancel those 3's. And so all you have left is the x plus 1 over y minus 2. So this one is a yes, that works. But look at the second one. You see that you have 3's on both top and bottom, but because both of them have a plus, it is not okay to cancel those 3's. Okay? On the second one, because these parentheses are being multiplied, it's kind of like two numbers being multiplied. So you can cancel as long as you cancel the entire parenthesis with the entire parenthesis, because that way you're canceling the factors of the factored form. And then your final answer is just what you have left over. So that's a yes. And this is probably one of the more common mistakes I see in higher level math. On this one, people automatically see those parentheses being the same and they try to cancel them. But even though the parenthesis is being multiplied by the 3, notice it's being added to the 2. So the numerator is not in factored form because of that plus, which means you cannot cancel those x plus 1's. On this one, it's a big whopping no. You cannot cancel those. So the way we're going to say it is never, never, never cancel terms. Okay? Terms are the ones that are being added or subtracted. Okay? You can only cancel factors because factors are the ones that are being multiplied. Okay? So when I look at number 1, and you've done these before, and we don't really talk about it, but the 3 is being multiplied by the x squared and is being multiplied by the y. So all of these terms are being multiplied. That's why it's okay to think about canceling. That's why it's okay to say, oh, the 3 over 12 will cancel and leave me with kind of like a 1 over 4. Or I can subtract my exponents and say x squared over x is just an x on the top. Or y over y squared is just a y on the bottom. And no, I know you don't need that one. I was just showing you the simplifying. Okay, but on this one, on number 2, you cannot just cancel these k's because they're both part of subtraction. They're terms. They're not factors. But you could factor first. So in the numerator, if I factor that using a common factor, I could write it as 3 times 2 minus k. And in the denominator, if I factor that using difference of squares, I could say k plus 2 times k minus 2. So now everything is in factored form. If I had the exact same parentheses, I could cancel. So now that brings up the question, can I cancel the parenthesis 2 minus k with k minus 2? In other words, does the order matter? Are they equivalent? So you got to ask yourself the question, well, let's think about if k was a 5. is 2 minus 5 the same as 5 minus 2? Well, they both equal 3, but one's positive, one's negative. So they're the same number, but they're just negative of each other. So it is okay to cancel as long as you leave a negative 1 in place of one of them. So what I actually have on top is 3 times negative 1 is negative 3. And in the bottom, all I have is k plus 2. Okay, so let's go to number 3. I have all terms. It's not in factored form. So the first thing I need to do is factor. So on top, I'm going to do a trial and error. So I know I need a plus and a minus, 2p times p. And to get 4, I can't do 2 and 2. I'm going to have to do 4 and 1. And I have to put the 1 here and the 4 here. Does that work? Well, that's going to be negative 8 and 1 is going to be negative 7. And I want positive 7. Remember, that's an easy fix. So I'll make this be a plus and this be a minus. And I know that'll automatically fix it. In the denominator, I'm going to take out a common factor of 5p. That's going to leave me with p plus 4. And so now I can cancel these factors, those parentheses. And what I'm left with is 2p minus 1 all over 5p. Okay. What about when you multiply fractions? Well, multiplying fractions, remember, don't you just go straight across? Like if I have 1/2 times 2/3, don't you just say 1 times 2 and then 2 times 3, right? You just multiply straight across. Okay, so in this case, I'm just going to think of this, it's just kind of like a big giant fraction. All right, so now can I go in and cancel? Well, sure. 7 goes into 14 2 times. 5 goes into 15 3 times. So on top I have 3. On the bottom I have 2. And I still have a squared over a, which leaves me an a on top. Okay, again, because it's multiplication, I can think of it as a big giant fraction. But there's like an implied parenthesis here. So the first thing I need to do is make sure everything is completely factored. So on top, I'm going to keep the 10 as is, but then I'm going to factor the difference of squares, x plus 5, x minus 5. In the denominator, I'm going to take out a common factor of 2, give me an x plus 5, and then that 5 minus x I'll leave alone. So now when I go in and cancel, the x plus 5's cancel. These can cancel and leave me a negative 1. And actually, 10 over 2 can cancel and leave me 5. So this whole thing just equals negative 5. Okay, how do you divide fractions? Well, I know you know this from your, again, I don't remember, 4th, 5th grade days. In order to divide fractions, isn't that the thing where you do the keep, change, flip, right? So you keep the first fraction, you change it to multiplication, and you flip the second fraction. Now, remember, there's an implied parenthesis around these subtractions. So I can cancel t minus 2 with 2 minus t, leaves me a negative 1. And actually, 6 over 8 simplifies. Doesn't 2 go into both of those? So that's going to leave me a 4 and a 3. So my answer is going to be negative 3 over 4. Okay. Let's try this last one. So, hey, this is honors pre-calculus. I think we can do a couple things at once. Here's what I'm going to do. Not only am I going to do my keep, change, flip, but in the process, I'm going to factor everything. Okay, so for that first fraction, let's factor the numerator using trial and error. I know it's got to be a 1 and a 1 and a plus and a minus. I think I need the minus with the x minus 1, because that way I'll get the negative x in the middle. In the denominator, I'm going to do a trial and error. I know both of the signs are plus, and I know I need a 3 and a 1. I think it's going to have to go that way in order for it to equal 5x, since they're both plus. If I'd put it the other way, I think I would have gotten 7x. Okay, so I'm going to change it to multiplication, and then I'm going to, right now I'm going to work on this one, but I'm going to put it on top because I'm flipping, right? So I'll put 2x and x, and let's see, in this case, I need a plus and a minus, so I think I'm going to go plus 3 and minus 1. I think that'll give me the positive 1 in the middle. And then on the bottom, I've got a difference of squares, 2x plus 1, 2x minus 1. And then I look and see if anything cancels. 2x plus 1, 2x plus 3. I can't cancel those x minus 1s because they're both on top. So I think that's all I can do. So on top, I still have 2 parentheses. I have x minus 1, and actually another x minus 1. So if I want, I could say squared. You don't have to. You could write both parentheses. And in the bottom, I have x plus 1 and 2x minus 1. So in this case, I did have some things canceled, but I still had a lot left over, and that's fine. Okay? Now, here's a situation where I have a fraction over a fraction, right? Well, that's the same as division. Now, I want to show you something, but then I'm going to show you what I think is a shortcut. So this is the same as saying this fraction, 10 over x minus 3, divided by this fraction, 5 over 2x minus 6. And by the way, I'm just writing all this out right now so that I can show you a shortcut. So if I were really doing this, I would do my whole keep change flip, right? So I would have 10 over x minus 3 times 2x minus 6 over 5. And remember, when you multiply fractions, it's the same as just multiplying straight across. So what's really happening is the 10 is being multiplied by the 2x minus 6, right? So look up here. The 10 is being multiplied by the 2x minus 6, and the x minus 3 is being multiplied by the 5. The x minus 3 is being multiplied by the 5. So because I know this process, instead of writing this all out, what I usually do on this type of thing, when I see a fraction clearly over a fraction, is I'll call it outer over inner. And it just saves me a step. So in other words, I'll go straight to saying, hey, I know the 10 is being multiplied by 2x minus 6. Those are the outermost terms, the very top and the very bottom. So I'll go straight to saying I have 10 times 2x minus 6. And the inner is going to be the x minus 3 times 5. So 5 times x minus 3. So I still want to, I could cancel the 10 and 5, right? But still, do you see that you could factor that 2x minus 6? So I'm going to do two things here. Not only am I going to cancel there, so I've got that 2, but on top, instead of 2x minus 6, I'm going to take out a common factor of 2 and leave an x minus 3, because if that's over the x minus 3 on the bottom, do you see what's going to happen? I end up with a total of 4. Okay, so let's do this. Again, we're in honors pre-calculus, so I'm going to combine some steps. I think you can handle it. If I'm doing outer over inner, okay, if I'm doing outer over inner, I know I'm multiplying this times this, right? But what I'm going to do is I'm going to factor while I do it. So the x squared minus 100 is x plus 10, x minus 10, and that's being multiplied by this, but I'm going to go ahead and factor that. Actually, it won't factor. I could try trial and error, but it's not going to work. So I'm just going to leave the x squared plus 7x minus 21. Okay, and now I'm going to do inner. So I have x minus 3 and 10 minus x. Neither of those will factor individually. So in this case, the only thing I can do to simplify is I can cancel these, and it's going to leave a negative 1. That's the only thing that I can do. I know it doesn't seem like you did it right, but that's fine. Sometimes not a lot cancels. I am going to write that negative out in front just because. And then I have x plus 10 and x squared plus 7x minus 21 over x minus 3. And that's the best we can do. Okay, so remember, when you're simplifying with fractions and everything, you can only cancel factors that are being multiplied. You can't cancel things that are part of addition and subtraction.